Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 47, Screened Base Actions. So hopefully you're starting to become convinced that actions have a lot of potential. They can automate a lot of code for us. In this video, we're going to create a couple more actions that are related to the screen. In particular, you might remember that in the past, in the Starfish Collector game, the turtle sprite is bound to the screen, so it doesn't go past any of the edges. Now, in order to make that happen, we had to remember in our update loop to call the bound to screen function. In this video, we're going to explore how to change the way that works a little bit. Instead, we can set up an action that automatically calls that for us. And that'll keep the size of the update method a little bit smaller. And this approach is kind of like specifying a set of behaviors for each of our sprites to have when they're initially created. We'll also try to do something similar with something called a wraparound effect. Right? Maybe we want certain sprites to be able to swim off the screen and wrap around to the other side. And we'll see how to do that too. And then once again, automate that process with an action. Therefore, we can specify that behavior when an object is created and not have to put it in our update function later. And so that's the plan. Let's go ahead and head over to our IntelliJ program. So here we are. And let's go ahead and see how bounding to the screen works. Let's go to the sprite class. I think there's a function called bound to screen here, and there is. Actually, it's probably good that we're looking at this code because did you notice that there's something we need to fix about this code? When we first wrote this code, the x and the y referred to the top left boundary of the turtle. But now, because of the way we implemented rotation, x and y refers to the center of the turtle. So I'm not sure if you noticed, but let's go ahead and run the game to show you what I'm talking about. Right, so the turtle can go halfway off the screen in these various directions, right, because we're only bounding x and y by 0. So we really do need to fix this code a little bit before we proceed. But it's a pretty easy fix. We just have to take into account half the width. All right, so let's say for bound to screen, here's the changes. Minus width divided by 2 is less than 0. Right, we're subtracting half the width because now that refers to the true left edge of the sprite, in which case we'll set the x to be width over 2. Same thing with going past the right edge of the screen. Right, we want to change this width to width over 2. And then for position.y, right, we need to do a similar calculation, but say minus height over 2. And then down here, we'll change this to height over 2 as well. And with these changes, bound to screen should work accurately now. Of course, let's go ahead and test. Let's see if that turtle stays on the screen. All right, so I'm going to try to move the turtle to the top. Nope. Move it to the bottom. Nope, I can't get past that bottom edge. What about over here? Nope, that turtle is going to stay on that screen. Very cool. All right. Now in our code, right, to activate this function, if I look at Starfish Collector, and let's maybe scroll down here. Right, at one point, there's a lot of code in update, so it would be helpful to reduce this. And see at the very bottom, there's turtle.bound to screen. And that could get accidentally forgotten. So what we'd like to do is incorporate this into the action framework. In the action framework, we'd like to automatically be able to call this method. So what we're going to do is we're going to go to the action class next. Right, we're going to add some screen-based actions. So screen-based actions. And the first one will be a bound to screen action. which will literally just call bound to screen for us. So public static action bound to screen. Now the information we need to call this function is how big the screen is. So we'll say double screen width and double screen height. Let's put those parameters on the next line so it's a little bit easier to read. All right, this function is going to return an action. So return a new action, and we'll use the parameterized version. So we just specify the function that should be run. It requires a target, delta time, and total time. Right, oh, and I want to use lambda syntax. Okay, so using that arrow notation to specify the code that should be run. And really, we're just going to call target bound to screen with these values, screen width and screen height. And then, well, we always want it to be bound to the screen. So this is another one of those actions that never terminates. So we're going to return false. And there we go. So now, if we add this action, then it will always stay on the screen. And what are we getting here? The error is, oh, we're providing doubles. We need to make sure these are ints. All right. And so there's our new action. Let's put a semicolon in there. And let's go ahead and rewrite a bit of our starfish collector code so it uses this new bound to screen action. And so now in the update method, I no longer need this line of code. Instead, when we first specify the turtle, let's go to this part where the turtle exists. The turtle is created. We set a position, texture, and physics. Let's also say turtle add action. This action is going to be, and from the action class, a bound to screen action. And the screen is 800 by 600 pixels. And so again, think of this as kind of setting up the turtle. And then we don't have to worry about adding anything to the update loop later. Let's go ahead and give this a run. And if this works, we should really see no changes from what we saw before. The turtle should be bound to the screen in the same way. And sure enough, I try to get past the edge of the screen and I definitely can't. I can't get past any side of the screen there. All right, so the bound to action works. All right, the last thing I'd like to add, I'd like to do something with this little fishy here. This fish looks like it's swimming, but it's really just swimming in place. So what I'd like to do is add the ability for this fish to wrap around the screen. In other words, to go past the right edge and then reappear on the left edge. Or I'd like to be able to go past the top edge and reappear on the bottom edge. And so I'd like to write a function that does that and then incorporate it into the action part of our library. So first let's go to the sprite class. And just like we have a bound to screen, it's going to help to have a function called wrap to screen. And incidentally, so spoiler, we're setting some of the groundwork for the next game we're going to create, which is based on the classic arcade game Asteroids. It's one of the first games to feature this wrap-around game mechanic. So let's call this public void wrap to screen. Again, it requires the screen width and the screen height in order to do its calculations. And, well, the code's going to look very similar to what you see in bound to screen. Right? Except in this case, once you go past one side of the screen, instead you set the position so you appear on the opposite side of the screen. So as funny as this sounds, I'm actually going to start by copying the code for bound to screen, even though it kind of feels like the opposite. And then, let's see, so this first if statement is basically saying if you've gone past the left edge of the screen. Actually, no, this is saying if you're right up next to the left edge of the screen. Now, I'm just going to write this code from scratch. Right? I don't want anybody to miss a minus sign or anything like that. Right, so going all the way past the left edge of the screen means that the x-coordinate plus half the width is going to be less than 0. Right, so in this case, The position plus half the width, that gives you the right edge of a sprite. We're interested in when the right edge of a sprite goes past the left edge of the screen, which is x equals 0. In that case, we'll set position.x so that it reappears on the right side of the screen. Right, so in this case, it'll be the screen width, set that equal to the screen width, and again, we've got to do plus this width over 2, so it appears, fully past that edge of the screen. All right, and then coming from the other direction, that'll be if position.x minus width over 2, that's the left edge of the sprite. If that goes past the right edge of the screen, in that case, we'll set position.x to be equal to minus half the width. And so this will position it just beyond the left edge of the screen if it goes past the right. Same thing for top and bottom. So if position.y plus height over 2 is less than 0, right? So the bottom edge has gone past the top edge of the screen. So the bottom edge of the sprite has gone past the top edge of the screen. Then position.y will be equal to the screen height plus the height of the sprite, that's right, over 2. Finally, if position.y minus height over 2 is bigger than the screen height, right? So this refers to the top edge of the sprite is greater than or goes past the bottom edge of the screen, then we'll set position.y to be equal to minus the height over 2. There shouldn't be 2 minus signs there, should there? Oh no, I think that's right. So that follows the same kind of pattern as before. Okay, I think we're good. So this is the wrap to screen function. Then when a character or a sprite goes past one edge, this will make it reappear on the opposite edge. And I immediately want to incorporate this into the action framework. So we're going to create a wrap to screen action. And so now I'm back in the action class. And wrap to screen is going to be very similar. So actually, I'm just going to copy bound to screen, rename it wrap to screen, and the function it's going to execute is going to be wrap to screen. That's that. All right, let's see how we can implement this in our game. Let's go back to Starfish Collector, and I've got my fish here. The fish isn't doing much of anything. Right now it's got an animation, which is fun, but it's just flapping its fins and it's not going anywhere. So I'd like to give it a physics object, which will cause it to move in one direction. So I'm going to set it to be a new physics. I do not want it to accelerate. Maybe the max speed will be, how fast these fish will go, 200 pixels per second, and 0 deceleration. Right, so this enables the fish to use physics. However, this is not setting the speed. This just sets the maximum speed and the default amounts of acceleration and deceleration. Now I need to set the speed of the fish. So fish.setSpeed, let's go ahead and set that to, I don't know, let's set it to 200. Now let's get that, and I can't say fish.setSpeed. That's a method belonging to the physics object stored in the fish. Right, so you need to give it a physics object, and then you can use the setSpeed method contained in the physics object to get that fish moving. Right, so if we were to run the code as it is, we should see that little fish just go directly to the right. I did not set a motion angle. That means the fish is moving to the right. Hey, there it goes. There it goes, and it's gone forever. But this is why we wrote the wrap function. So let's also say to the fish, fish.addAction. And this is going to be from the action class a wrap to screen action. I'm going to tell it the screen is 800 by 600. All right, and that should actually handle wrap. Let's go ahead and run this. So if the fish goes off the screen, then it should reappear on the other side. And there's our little fish. It's going right across. And it should reappear over here. And sure enough, it does. And so now we've added a wrap function. Right, just to test this, let's also give the fish some kind of a motion angle. And so fish.physics.setMotionAngle. Let's give this an angle of, I don't know, 45 degrees. And let's see how that works. All right. So there, oh, okay. It looks a little bit funny because the fish is not facing the angle it's moving in. Before we even test that, I'd like to go ahead and say fish.setAngle also to 45 degrees. Oh, that was a funny looking fish. It was not looking where it was going. Okay, so set angle changes the angle of the image, right? And set motion angle changes the angle at which it's moving. Right? Those two things aren't set to be the same by default. You just have to set both. Right, there goes our fish. It disappears over here, so it should reappear around here. All right, it's probably going to disappear right around here, so I'd expect it to reappear over here. Oh, and there it goes down there, and oh, now here it comes here. Right, hey, you've got a little fish. And that's just a fun little bit of scenery to add to our game. Gives a little bit of that professional polish. That's looking really fun. All right, so I think that's all we're going to add to the action framework. I'd really like to work on polishing up this game a bit, right? And then we're going to call it closed for Starfish Collector 2.0. Although we might talk about ideas for 3.0, that'll be up to you to implement if you wish. But that's it for this video. Thanks for watching.